Hello and Assalamu alaikum everyone. I am Sovon Chakraborty, ID 22366023. I am here to present my individual presentation of a research paper. I am submitting this presentation to Anajat Anip Russell sir. Now I will go through the title of this paper, which is Affinity Aware Resource Provisioning for Long-Running Applications in Shared Clusters. The name of the authors are provided here. You can find this paper in the given link. The DOI number of this paper is also provided here. At first, we'll go through the abstract of this paper. Resource planning or resource provisioning plays a pivotal role in determining the right amount of infrastructure resource to run applications and reduce monetary cost. A significant portion of production cluster is now dedicated to long-running applications. Authors present an affinity-aware resource provisioning approach for deploying large-scale LRS in a shared cluster to multiple constraints. Authors investigated a broad range of solution algorithms which fall into three main categories: application-centric, node-centric, and multi-node approaches, and tuned them for typical large-scale real-world scenarios. In case of time, best results are obtained by the application-centric algorithms, and in case of primary solution quality, the multi-node algorithms have shown best result. Authors have given a detailed research literature. They have found the following gaps, which are number of computing nodes for LRS or higher in terms of resource provisioning. Comparison between algorithms are not shown previously. No such approach has been taken into previous studies, though some algorithms have been proposed but fine-tuning was not done properly previously. The contributions of this research paper are formulating a resource provisioning problem to address temporal resource request and application level affinity constraints, devising an algorithm suite to provide adaptable solutions to a variety of real-world scenarios, selecting by extensive computational experiments a collection of best performing algorithms that can effectively handle large-scale LRA deployment, focus on the use case of Alibaba Tianchi dataset, elaborating algorithm recommendations, providing a trade-off between computation time and solution quality when confronted with different scenarios. The motivation of this paper are stated by the authors such in a way that LRS require hours or even months or a longer period of time for completing tasks. Even many nodes or computation nodes are required that increases the cost of the total system. The authors are focused to propose an algorithm that will allow the LRS to use or reduce the number of computing nodes via request and response manner to serve user request. That includes streaming also. So an algorithm is proposed and fine-tuned for reducing the time and cost of a whole system. The following challenges have addressed by the authors while doing this research: multidimensional and time-varying resource requirements, application level affinity constraints, and large-scale LRA deployment. Launching tens of thousands of LRS has now become the norm rather than the exception for cloud service providers in the face of new cluster initialization that increases the management complexity of deploying large-scale LRS. As we mentioned earlier, in case of time, application-centric approach perform best. So the algorithm here is, at first we'll activate a computing node, then we'll look for any look for the unallocated LRS. We'll pick one and denoting it as I. Then while until the replicas of the LRS are not allocated, we'll increase the computing nodes. Until the whole task is completed, we'll perform the same procedure and increase the number of nodes. Finally, when the computation is done, we'll remove that unallocated LRA from the list as it has been allocated already. Authors have set some performance evaluation criteria. These are effectiveness, execution time consumption, instances with varied density, space complexity, and time complexity of the algorithms. The experimental findings are given here in a pictorial format. The MEDEATP shows best result in case of effectiveness and log scale of time consumption. You can have a look here. Authors are yet to resolve some of the major concerns, which are actually practical concerns. These are integration into multi-stage cluster management, runtime management considerations, other objective considerations. These are practical concerns that have not yet addressed by the authors, but they are focusing they will resolve all these issues in near future. In future, authors are planning to investigate automatic algorithm selection from the proposed algorithm pool, automatic tuning of the selected algorithm. They also plan to integrate the proposed heuristic into Kubernetes to evaluate how theoretical study can navigate the runtime execution. In conclusion, we can say authors are focused to propose an algorithm for LRS and proper clustering. That's why they have activated the multi-bean approach that help to do proper scheduling. Apart from that, to reduce the amount of time, they have proposed an algorithm with fine-tuning, which is application-centric algorithm. Careless or no planning often leads to poor utilization and performance of the cluster. That's why they're carefully proposed an algorithm and planned to reduce the overall cost of our system. That's all from my presentation. Thank you, everyone.